for those of you, I guess the first question we talked about we did in class, all right? So that should, I think that was fair. The second one, we didn't do anything like that in class. The idea was, if you watched the video, could you handle that? So for those of you who did watch the video, and I'm not calling people out here, but how many of you felt like watching the video was enough for you to be able to do this? Show of hands. Okay? Little, maybe somewhere in between? Okay. What I'd like to do, since this is something I haven't done, let's actually go through this, all right? Let's go through this particular question. And I'll write down next to the picture up there, I'll write down the problems, and we'll just kind of go through them one at a time. So the first question was to find the limit as x approaches -3 with the little minus sign up here, f of x. So what does that mean? Okay, so we're looking at our graph, right? And we're looking at an x value of -3, which if you go on the x-axis, right, x-axis here, -3 puts you out right there, doesn't it? And you imagine that you're walking along the x-axis, walking along the function, coming in from the left side. So the left side is given to you by what? The negative up here or the negative in front of the 3? The negative up here tells you left side. The way to remember that is, remember the negative numbers on the left side of 0, the positives are on the right. So you're going to be coming in from the left side. So you walk along the function. So here I am, I'm walking along in green. By the way, we changed rooms because the colors on this projector are much better. Okay? Like you can really tell what green and yellow and red and stuff are here. So you walk, 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 and then what you're looking for is where you're headed, meaning the height of your function. How high off the ground are you as you come in from the left side there? So what is it? Looks like it's approaching whatever this is, and that's 3, right? So that's your answer. Any questions on that? Okay. Now the next question said, what is the limit as x approaches -3, but this time a little plus sign? So you're still going to start at an x value of -3, right? So the yellow here that I have highlighted is still the same. I'm going to get the green stuff out of here. So I'm still looking at -3, but now I'm walking along the function on the left side. So I'll do this one in like an aqua blue. I said right side. Right side. So the plus sign here means I come in from the right. So I'm walking along the function somewhere over here. And where am I headed? I just keep dropping down and down and down and down forever, right? Down forever is -infinity, isn't it? So the result here would be -infinity. Questions on that? The next question, part C, was what's the limit as x approaches -3 of f of x? And this time, there is nothing on the top right of the -3, right? So what does that mean? And this is where you had to watch the video or read the book. That means that you have to look at both sides. You have to come in from the left and the right. And the only way you can actually put an answer here is what? If what? If where you're headed as you come in from the left is exactly the same as where you're headed as you come in from the right. And when we come in from the left, what did we say the answer was? 3. And when we come in from the right, it's -infinity. Those two are not the same. Therefore, what do we write? Does not exist. D-N-E. That's not an O. I had a student a few semesters ago that was like, why do you keep writing 1? I'm not writing 1, I'm writing D-N-E. Does not exist. All right? Questions on that? So I'll do it in purple. You have to check both from the left and the right to figure this one out. Make sense? Okay, last question for this, well, not the last one, this is part D. It says just what's f of negative 3? So yeah, this is actually now not even a calculus question, is it? All that's asking is what's the value of the function at negative 3? So just walk to the left, 1, 2, 3, and look for where your graph exists there. And in this case, I have an open circle here, which means there's nothing there, right? I have a solid dot here, which means that's exactly where the function is defined. So what's the height of that point? The height of that point is 1. So f of negative 3 is 1. Make sense? No one has a question? All right. Let's do the next, boy, there's a bunch of these. I'm going to erase all this, so I still have room over here. Limit x approaches 2 from the right, from the left, of f of x. So the difference in this problem now is that instead of looking at negative 3, we're looking at x value of what? Positive 2. So I march to the right 2 spots. There's 2 right there. And I'm looking at my function coming in from the left side, so I'll mark it in green. So as I'm approaching 2 from the left side like this, how high is that approaching? It looks like it's approaching 4 up there, isn't it? Looks like it's getting closer and closer to 4. So the answer is 4. And then what would be the limit as x approaches 2 with a little plus sign here? That means I come in from the right now. So same thing, I'll highlight this one. Let me do purple. Come in from the right. That means I'm approaching 2 from the right. I'm coming up like this, and lo and behold, I'm headed to the same place, aren't I? So because I'm headed to the same place, the answer is also 4. Now, the next question says, well, then what's the limit as x approaches 2 of f of x? That means I'm not telling you left or right, which means you have to check both left and right. And we already saw that from the left it was 4 and from the right it was 4. And if they're the same, then the answer is 4. And then what is f of 2? So what is the function defined to be at 2? So this is no longer a calculus question. This is a college algebra question. There is no function at 2, right? You go out to 2, you look up and down, you don't see any graph, do you? So what do you put, though? Undefined. Okay? If you write does not exist, that is wrong. Okay? Does not exist. Now, on this quiz, I won't necessarily get too angry about that, all right? But down the road on a test, we reserve does not exist for limits. Okay? When you're doing a limit, and that limit doesn't go to the same place from both sides, we say it does not exist. But if you're saying what's the function's value at a specific point, and it's not defined, well, then it's undefined. There's a difference. No, because 0 with the slash means empty set, which, yeah. You're not saying, well, when you're saying what is f of 2, you're trying to say that the function doesn't exist there, like the function is not defined at that point, so undefined. All right. Limit x approaches 5 from the, which side there? From the left. So I'll do this one without any colors. So where are we headed? Here's 5, right? I'm coming in from the left side. I'm headed down towards a y value of -2, right? So -2. What's the limit as x approaches 5 from the right side this time? What is it? As I come in from the right, that's over here, I come in and I'm actually constant, right? I'm just the same value the whole time, and I'm actually 2 the whole time, -2 the whole time. So I'm headed to the same place, which means that if we ask what's the limit without giving you the left or right, since they go to the same place, the answer is -2. And finally, what is f of 5? Our function is defined there, isn't it? I mean, it's a solid dot there. At 5, it's -2. We're going to, and if you watched 1.5 video, this is what we need right here. We need this limit to exist right here, to be equal to -2. And if the function is also -2 at that same place, that means the graph is going to the same point, and at that point it's defined, then we say that the function is continuous there. But that's 1.5, and we'll get to it if we can today. All right, that was the quiz. Yes. At an open circle, like what's happening at x equals 2 here, that would be this would be discontinuous there, but it would be removable because you could always fix it by just filling it in. That's called a removable discontinuity, as opposed to this one. This is not removable. You can't just fill in a dot and make that thing. Think about it as like trying to draw it without picking up your pencil. Like if I just fill this dot in right here, I could just draw without picking up my pencil. That's removable, meaning I can just simply fill it in and I'm okay. Over here, there's no way to draw this without picking up my pencil. Eventually, I have to pick my pencil up off the page and come down here and draw. So that's a non-removable discontinuity. All right, let's get back to today. Let's see. So we did quiz, and now we're gonna finish up 1.3. What I just showed you was kind of me doing 1.3. The important things about this whole quiz was the notation, okay? What all this notation means, and you know the left and the right. Anyone know what we called those? Left-hand, right-hand limits, or they're also called single-sided limits. All right, so anytime you have a plus or minus in the top right-hand corner, that's going to be a single-sided limit. Anytime you don't have that, it's just the limit at that point. Oops. All right, so now I'm going to refer back to our notes. We ended up last class at 1.3.8. And then, assuming you watched the rest of the video, the only thing left to talk about here is 1.3.17, where I was supposed to do an example. So that's what I'll do now. All right, so 1.3.17. Everyone has their notes? It says, drawing a function given some information about its behavior. Sketch an example of a function with the following properties. Does everyone have this? Do you have the notes? I have a copy, that's why. Anyone else? Anyone else need the notes? We're doing 1.3.17. Okay, so first thing I need the limit as x approaches -2 of the function I draw to be equal to 3. So how in the world are we going to do this? Let me first put an axis in here. Now, where am I supposed to be approaching on this first one here? -2. So let me go to -2 on my graph. 1, 2, here at -2. What I need is for the limit at that to be equal to what? 3, which means that the height The function should be approaching a height of 3. And is it from the left or from the right? Both, right? Both. Because on the problem it says limit x approaches -2 of the function should be equal to 3. Because there is no little plus or minus in that top right-hand corner, that means I need from both sides to go to 3. So I'm going to put